Alright, so this is a run through for practice test 2. And the first question was asking you to describe the following sequences. So here are the 3 sequences. Starting with A, the first thing that I usually do is I start looking at the differences between each number. So this one, it went down by 10. And then you go down by 9 for this set, down by 8, down by 7, and then the pattern continues on. So if you were to describe this pattern, you could say that it decreases by 1 less than the previous one each time. And then you could keep writing it out if you wanted. For B, I did the same thing. I just made the letters into their corresponding numbers. And I found that that changes by 1. This changes by 2 letters. So this one A, the next one will be B. And then C, D, you change by 2 letters. D, E, F, G, you're adding the third. And you're adding 4th, 5th, 6th. And you can continue the pattern from there. So you increase how much you're adding to it by 1 from the previous one. And then for the third one, whenever I see numbers and letters together, I usually break them down into the 2. So I started with the numbers. And this first one increased by 2, as well as the second one, and the third, and the fourth. So that's a pretty consistent pattern with the numbers. And when I looked at the letters, that increased by 2 letters. This one actually increases by 4 letters. C, D, E, F, G being the 4th. And then by 6. And then by 8. So there's a pattern where it increases 2 more than the last one. And you can continue on the patterns from there. Alright. So for question number 2, it says that when a certain ball dropped from any height, bounces 1/2 the original height. If it was dropped from 60 feet, so here we're going to write this down. This is where drawing a picture is important. So we're going to drop it from here. So when dropped from 60 feet and allowed to bounce freely, what was the total distance it traveled when it hit the ground for the second time? So I'm going to go like this. So it goes down once, then it bounces up, and the thing told us it bounces to half its original height. This is going to go up to 30 feet, then it comes down, and that right there will be our second time it hits. Okay, so now all we have to do is count. So we come down once. That first time it's going to be 60 feet that it travels total. Then it's going to bounce up to that apex there, and because it only goes half the original height, it's only going to go up to 30 feet. So let's add that 30. And then it's got to come down because we're looking for the second time it hits. So that means it's going to come down and add another 30 feet to how much it has traveled, which gives us a total of 120 feet, which is the total distance it has traveled by the time it hit the ground for the second time. All right, so let's work through problem number 3. All right, so it tells us that 1/10 of a string is colored green. 1/20 is yellow. 1/30 is orange, and 1/40 is red. And then the remainder of the string is 950 inches long. And violet. So here is one way that I started it. There are obviously other ways that you could do it, but this is what I chose because it was one of the easier ones. So I wanted to find out how much this came to altogether. So we're trying to find the orange. So I wanted to add it together. So 1 over 10 plus 1 over 20. So one way you could do it is you could just do 10 times 1 and then 20 times 1 and then multiply the two so you get the same denominator. So 10 times 20 is 200. So 10 times 1, 20 times 1 is just going to be 20 plus 10 over 200, which equals 30. Wow, for a second I was multiplying those. 30 over 200, which equals 3 over 20. So this is what 1/10 and 1/20 equal. So now let's add in the 1/30. So 3 over 20 plus 1 over 30. Okay, now we're going to multiply this by 20 and this by 30, and same down below. So 20 times 30 is 600, and then 3 times 30 is 90 plus 20. So that gives us 110 over 600, or 11 over 60. So that's those added together with that. Now the last one we have to add in is the red string, which is 1/40. So we're going to add in 1 over 40. Then we're going to multiply again, 60, 40, and 60 times 40 is 2,400. And then 11 times 40 is 440 plus 60 equals 500 over 2,400. And you can cross these out and you get 5 over 24. So all these together make up 5 out of 24 parts of the string. The remainder of this is just the other part. So 24 minus 5 means that the remainder is made up of, let's change colors. So if all of this is 5 out of 24, then 19 out of 24 of it is made up of the remainder. So 950 over the total amount of string, which we'll represent as x, is equal to 19 parts of 24. And then we can just cross multiply. So when we do that, so we get 22,800 equals 19x. Divide our 19s, and then x equals 1,200. So that means that the total length of our string is 1,200 inches. Now, why is that helpful? Well, because we know that the orange is 1/30 of the total length of the string. So all we have to do is take this 1,200 and divide it by 30. And that gives us 40 inches. So dividing it by 30, because we know orange is 1 part if you divided it into 30. So we divide it by into 30, and that means 1 part of that is 40 inches. And since orange is only 1 part of 30, the orange is 40 inches. There's your answer. All right, so for problem 4, a guy pays $100 for a table on KSL. So he pays 100. Well, let's not write that sideways. So he pays $100, and he wants to set this new price, the retail price, in such a way that he can offer a 5% discount on this new price and still make a 10% profit. What should the resale price be? Okay, so let's start. So he paid $100 and he wants to make 10% of that back. So we can multiply that money by 0.1, which is equivalent to 10%. And that means he needs to make at least $10 above that. So we can just add them together. And that tells us that the customer needs to pay $110 even after the 5% discount in order for him to make 10% more than he paid for it. Okay, so now that we know that, we can say X will represent this price that we're looking for, what he has to sell it at. Now, the customer needs to get a 5% discount. So if we multiplied X times 1, it would just be the same price. They wouldn't be getting a discount at all. But if we multiplied it by 0.95, that's equal to the customer paying 95% of the price, meaning they get 5% of the price off. So if they pay only 95% of this price that he's asking, it needs to equal $110. So now all we have to do is divide by the 0.95. $110 divided by 0.95 equals $115.789. And one of the important parts about problem solving is that you go and you look back. So to make sure this works, we could say, okay, so if he does sell it for $115.789, or you could round it up to $116. So the customer gets 5% off, so they only pay 95% of the total price. What does that equal? And when we multiply that by 0.95, it equals 110. So he gets all that money he spent back, plus the 10%, which is the $10. All right, so for problem 5, it says one watch beeps every 4 minutes and another watch beeps every 9 minutes. If both watches beep at noon, what is the second time that both watches will beep together? So one of the problem solving things we learned was how to make a list. So let's look at this. So we wrote down that they both beep at noon, and then I wrote down each time that they would beep. So every 4 minutes, this watch beeps, and every 9 minutes, this one does. And then what I did is I looked for times that they had in common. And the first time that I see in common is 12:36. So that is 36 minutes after they first beeped. So, following that logic, they should beep in sync once every 36 minutes. Now, some of you will notice that you could have gotten this by multiplying 4 times 9. So 4 times 9 equals 36. So the first time that those multiplied by each other come together tells us that's the first time they're going to beep. Now the thing is, it asks when will both watches beep together for the second time. So all we have to do is take these 36 minutes and add it to that first time. So they first beep again after noon at 12:36, and they should beep again in another 36 minutes. So 12:36 plus 36 minutes. 36 minutes is 1/2 hour, so that means that this would beep again at 1:12 p.m. And if you calculated it just from the beginning, if you said, okay, so 4 times 9 is 36, and it needs to do it twice, 36 plus 36 is equal to 72 minutes. 72 minutes is also equal to 1 hour and 12 minutes when you divide it by the 60. So all you would have to do is add 1 hour and 12 minutes to noon, and that would tell you that it beeps for the second time at 1:12 p.m. So you could do it either way. This is just if you decide to use a list. All right, for question number 6, it says that city P is 300 miles away from city Q. Car A starts from city P at 3 p.m. and it travels towards city Q at 60 miles per hour. And then another car starts from city Q at 4 p.m. and travels towards city P at 20 miles per hour. We're asked to find what time the cars pass each other. So after visualizing and drawing it out, I decided to make this kind of like a number line. So city P is 1, or you could say 0. So when you're at city P, you're at marker 0. And then when you're at city Q, you're at 300. So I made a table over here, and I said car A leaves, as it told us in the directions, at 3 p.m. So at 3 p.m., it's officially at mile 0, marker 0. And then at 4 p.m., it travels 60 miles in 1 hour, so it will have traveled 60 miles by 4, so it'll be at the 60-mile marker. And then in another hour, it'll travel another 60, so it'll be at the 120. And then you keep going down for each hour, and he's going to reach city Q by 8 o'clock. So I stopped keeping track there. Car B doesn't leave until 4 o'clock. Now, he hasn't gone 300 miles at this point. He's at the 300-mile marker. So E is traveling 20 miles per hour. So he's going to be going down numbers because I made that a scale. So he'll be at mile marker 280 by 5 o'clock. And then you subtract another 20 because he's going to move 20 miles in 1 hour down that way. So he'll be at 260, and then 240 and 220 and so on. And when we look at the numbers, it's easy to see that at 7 p.m., 7 p.m., they're both going to be at marker 240. And there's our answer. This is why I chose to label them along the number line rather than how many miles they had gone, because if I just have him start moving and count down from 300, I know exactly where he is in relation to this guy. All right, so for question 7, it says that a ribbon is separated into 2 pieces with a knot tied so that the ratio between the 2 sections is 2:7. So we have our string right here. So there is a knot somewhere, boom, so that there are 2 parts over here and 7 parts on this other side. So 1, 2, 3, 4, 6, 7. I know that's not even, but let's pretend it is. See, each of these parts are even. All right, so the total length of the rope is 81 feet. What is the length of each section of rope? So let's just make this obvious here. There is our knot right there. So to one side there are 2 pieces, and then to the other there are 7 pieces, which gives us our 2:7 ratio. Which also tells us that we have a total of 9 pieces of rope. We've put it into 9 different sections, and each section is different. So 2 plus 7 equals 9. So all we have to do now to find out how long each section is to take the total length and divide it into the number of pieces that they divided it up into in the problem. And that equals 9 feet per section. Bam. All right, so for problem 8, what we're doing is solving for proportions. So we can just cross multiply each of these for a quick way to do this. So 4 times 20 equals 80, and 80 is equal to 8y. And then all we have to do is divide by 8, and then we know that 10 is equal to y. And then one of the steps to problem solving is looking back, and if you plug it in, if you do 4 over 10 equals 8 over 20. 4 over 10, when you simplify it, equals 2 over 5. And 8 over 20, when you simplify it, so you could divide both by 4. 8 divided by 4 is 2, and 20 divided by 4 is 5. So you can confirm that they do equal each other. So 10 is y. And you can do the same things with these other ones. So 3 times 8 is 24 is equal to 12x. Divide by 12. X is equal to 2. And you could once again plug in and find the same answer. 63 is equal to 9z. Divide 7 equals z. All right. So, for the last problem that we have here, it says the quadrilateral ABCD is similar to HIJK. So find the following. So let's write this out because that first part was important. So it said ABCD is similar to HIJK. So we learned in class that the order is important. So that means A and H come first. So when you follow this order, you go around this way. When you follow this order, you go HIJK. So B to I, J to C, K to D. So what I like to do, because this already tells us which parts are congruent, so A and H, so I could just put in H over here to remind myself really quickly without having to look over here which ones are congruent. So B comes next, and what also comes next on here is I. So I just put a little I there to help me keep track. And then C, the third one is J, and then the last one is K with the D. So that tells me that if I want these to be congruent, I would just flip this one over, and then it would be in the same position as this figure here. So it's important to look at this if it gives you a similarity statement. All right. So the first thing it asks for in A is their scale factor. But to do a scale factor, you need to set up a proportion. And unfortunately, when you look at this, you don't have enough for both sides that you know. So you know 12 and 24, so those are corresponding sides. Well, that's great, but the 4 over here is corresponding to this z, so we don't know z yet. The y's, we don't have anything there, so we don't know what those are. And this 20 is corresponding to an x. So that means we should move on to the next question. So B says find the values of x and z. So those, so let's just write B over here. So let's start with x. So an easy way to do this is to take, so we know these numbers and they don't have any variables in them, so let's use this. So x over its corresponding angle, which is 20, is equal to 12 over 24. So we put the smaller triangle in the numerator and the bigger triangle in the denominator. So we kept them in the same pattern, so this is a good proportion. And then all we have to do is do 12 times 20 and x times 24. So 12 times 20 is 240 is equal to 24x. So x equals 10. And you can plug it back in to see if that works, and it does. So then I just come over here and I write a note to myself, okay, x equals 10. All right, so now the next part of the question asked for the value of z. So I just set it up the same way. So z, this side, corresponds to this side. So z over 4, and I'm switching it around so the big triangle is now in the numerator and the smaller triangle, the smaller quadrilateral, will be in the denominator. So z over 4 is equal to 24 over 12. And once again, you're going to cross these. So 96 is is equal to 12z, which means z is going to equal 8. And I write that in here, and if you plug it in, back in, it works. So now we can look at our scale factors because we filled in as many of these sides as we can. So a good way to look at scale factor is to take, this time, the same parts of the same shape together. So for instance, we can take this 4 over here over this 10 is equal to, and now we need to find the corresponding sides, so 8 over 20. So hopefully this makes sense. So the smaller triangle's proportions here, when you multiply them by something, equal the same proportions over here. So what would you multiply these two to get this new size? Well, 4 times 2 would give you 8. And it also happens that 10 times 2 would also give you 20. So you're scaling it up by 2. So all of these follow this rule. So 12 times 2 equals 24, 4 times 2 equals 8, and 10 times 2 equals 20. And I'm sure it would follow it for the y's too if we had that. So our scale factor would equal 2. Then the last thing that it asks us is to write the congruency statement for each pair of angles and each pair of sides. So it kind of had you work backwards. So if you, this is a good way to encourage you to read all the problem and then go for it. So we kind of started with C when we did this up here. We just didn't write it out. And then we moved to question B and then to C. So let's put C down there. So it asks us to list the angles and then the sides. So for the angles, we wrote up here, we can just look up here now to find out. So angle A is congruent to angle H. Angle B is congruent to angle I. And then we can just continue that. J. Okay. And then when we do the sides, it's the same thing. We've already written which one it's congruent to. So if we look from A to B, so side AB is congruent to side, well, H and I are next to them, so we can just say congruent to HI. BC and then IJ right next to each other. Don't even have to look at the other one. CD is J to K. D to A is K to H. And then there you go. It's as easy as that. And that is practice test 2.